Hey there everyone, welcome back. Today's lesson we are looking at radicals again, and we're going to take a look at how we multiply and divide radicals. So it's actually fairly straightforward. The main thing we need to make sure of when we're multiplying radicals is that they have the same index. And so long as they have the same index, then we can multiply their coefficients together and then multiply their radicands. In sort of a general form here, we could say that we can multiply the coefficients on the outside and then multiply the radicands on the inside of the radical, so long as the index is the same. So if I have 2 root 7 times 4 root 75, I can just multiply the coefficients on the outside and then multiply the radicands together. So 2 times 4 is going to give me 8, and then 7 times 75 is going to be 525. Now the thing to be careful of is this is a little bit like when we did fractions. We can just multiply them all together, but we always have to double check at the end to see if we can simplify. And actually right at the beginning would have been a better time to simplify, because root 75 is actually not the simplest form. But regardless, now that I'm here, I'm going to take a look at 525, and I can see that I can actually split that up into the square root of 25 times the square root of 21. And so the square root of 25 is 5, and 8 times 5 is 40, so this just becomes 40 times the square root of 21. So as I say, just go ahead and multiply coefficients, multiply radicands, but at the end, make sure you simplify if at all possible. Now, this is still true if we're trying to multiply terms that are, for example, binomials, and so on. And so if I have, like this example here, 7 root 3 times 4 bracket 4 root 5 minus 6 root 3, I'm just going to go ahead, I'm going to multiply the first term, and then I'm going to multiply the second term. So 7 times 4 gives me 28. Root 3 times root 5 is root 15. And then 7 times negative 6 is negative 42. And root 3 times root 3 is square root of 9, which I recognize the square root of 9 is really just 3. So this is like 42 times 3. Which is really just 126. So my final answer should be 28 root 15. Now that's actually just a good reminder at this point that anytime we have the square root of something multiplied by itself, like root x times root x, the answer is just x. So root 3 times root 3, I really should have just written as 3 from the get-go. Okay, so if I have now two sets of binomials, it's a little bit like our expansion from when we looked at quadratics, where we're going to kind of FOIL it out. So we're going to multiply the first terms together and the last terms together, then the inside terms together, and then the outside terms together, and see what we get. So 8 root 2 times 9 root 5 is 72 root 10. And then 8 root 2 times 6 root 10 is going to be 48 root 20. Negative 5 times 9 root 5, well, there's no radical there, but I can still just multiply the coefficient. So that's going to be minus 45 root 5. And then negative 5 times 6 root 10 is going to be minus 30 root 10. So in order to clean this all up at the end, there's two things I need to look for. One, can I collect like terms? And two, can I simplify? One thing I can do is I can collect the like terms of root 10. So 72 root 10 minus 30 root 10 is going to be 42 root 10. So that's a little bit cleaner. But I can also simplify root 20, because that can be written as 48 root 4 times root 5, which is going to simplify to 96 root 5 minus 45 root 5. So just fill in all my blanks here that I skipped over, and I can see here I've created another like term, so I can go ahead and combine those. So I've got 42 root 10, and then I've got plus 51 root 5. And that is my final answer, and leave it like that. So dividing is going to be actually quite similar to multiplying, which is we're just going to go ahead and do it. Divide the coefficients, divide the radicands, so long as the indexes are the same. So 4 times the cube root of 6 over 2 times the cube root of 3. Well, 4 divided by 2 is just 2. And then cube root of 6 divided by cube root of 3, 6 divided by 3 is 2. So that's going to be just the cube root of 2, and that's that. Now we'll point out that in addition to the other restrictions where our radicands can't be negative, this is also introducing kind of a rational situation where I also can't have a denominator that's equal to 0. So I just have to keep that in mind with any of my restrictions. So take a look here. So root 24x squared over root 3x. Now, you don't need to do this, but I'm just going to do this on this first one because it's our first time kind of thinking about it. Divided by root 3 times root x. And you can see here that the terms inside the radicand, the numbers, root 24 over root 3, I can just think of that as the square root of 8. And then root x squared over x, well, x squared divided by x is just x. So really, this just becomes the square root of 8x. Now, you might at this point look back at that example there and say, well, the square root of x squared, shouldn't that have just been x anyways? And that's true, but that actually would have meant I wouldn't have been able to divide it out. So I'm just left it as it is. All right, the next one here, I've got 2 times the cube root of 51 divided by the cube root of 3. Well, 51 can divide by 3 to give us 17. So this is just 2 times the cube root of 17. Okay, and that is it for multiplying and dividing radicals.